Hello, let's take a look at your MT3 LT8 seminar. Um, you do questions 1 through 5. I'm not going to go over those on the video. And if we look at our state standards, we have 1. We're going to look at slope for parallel and perpendicular lines. As we work through our lessons, I would like you to concentrate on making sense of problems and persevering in solving them. So it'll be multi-step questions. Construct viable arguments and look at the reasoning of others, and look for and express regularity in repeated reasoning. I want you in this lesson to classify lines as parallel, perpendicular, or neither by looking at their slopes. I want you to classify parallel, perpendicular, neither by comparing equations of lines. You did some of this in Algebra 1. We're going to take it a little bit further now. As a review, remember slope is the change in y over the change in x. You usually see it written as change. That's what that triangle means. It's a Greek letter delta. It means change. Maybe you've seen it as rise over run. Or maybe as a formula y2. Come on, you. That's supposed to be a 2 if my pen would work. Minus y1 over x2 minus x1. All of them will give you your slope. Remember, if the line goes up, it's got a positive slope. If it goes down, it's got a negative slope. It's horizontal at 0. If it's vertical, it has an undefined slope. Sometimes you see that written as no slope, but it's an undefined slope. Now, if we have parallel lines, our slopes should be kind of common sense. They're going to be the same because they have to be the same distance apart and always be the same distance apart, so they have to rise and run at the same proportion. Remember, vertical lines have an undefined slope, so we're just going to say vertical lines are parallel. So anytime you have a vertical line, it's going to be parallel. Now, perpendicular, that one you did in algebra, but you might have forgotten. Okay, that is, we have to multiply our slopes, and they have to be -1. Or opposite reciprocals. So, for example, if two lines are perpendicular, we'll start here with a number. Let's say 3 over 4. To be perpendicular, it would have to be -4 over 3. Put it in a generalized A over B. Perpendicular to that would be -B over A. So it's always the opposite sign, and you flip them. Now, you flip them because y becomes x when you turn it 90 degrees, and x becomes y. That's the rotation we learned in our transformation units. You cannot look at two lines and determine if they're parallel. Some people think, I'll just graph these on Desmos and I'll see if they look parallel. Looks don't mean anything in geometry. We got to go by properties. So let's do it here. Now, I kind of looks like they're parallel, doesn't it? So I won't be surprised if they're parallel, but you got to show me they're parallel by looking at their slopes. So let's look at the slope of AB. So the slope of AB is going to be 2 minus 6 over -9 minus 3. You could have said 6 minus 2 and 3 minus the -9. You get the same answer. 2 minus 6 is -4. -9 minus 3 is -12. Reduce our slope, we get 1/3. Now let's turn around and let's find the slope of CD. So I'll go 3 minus 4 over 2 minus 5. 3 minus 4 is negative 1. 2 minus 5 is negative 3. A negative divided by a negative is a positive. I said positive, but I wrote down negative. Okay, there we go. Positive 1/3. Since those two lines have the same slope, I can say AB is parallel to CD. Like I said, looking at my graph, that doesn't shock me, but you got to do the slopes to guarantee it. Just because they look parallel doesn't mean they are. Now let's take a look at the next two examples. We're going to kind of do the same thing. I've graphed them for you, so you didn't have to graph them yourself. Let's start with letter A here. And I'm going to look at the slope of R to S. So R is negative 8, negative 3. S is negative 6, or is positive 6, 7. So then what we're going to do, we are going to, we are going to subtract our Y's. I think S comes second, so I like to do that. So I'm going to say 7. Now remember, when you subtract, you're not subtracting just because it has a negative sign. So it's 7 minus a negative 3 over 6 minus a negative 8. So 7 plus 3 is 10. 6 plus 8 is 14. So divide by 2, I get 5 over 7. Now it kind of looks like they're perpendicular. So think, if they are perpendicular, the slope of TU should be negative 7 over 5. So let's turn around and let's find the slope of T to U. Notice I'm using negative 4, 6, and 0, 0. Oh, that works out really, really nice, doesn't it? Because if I take 6 minus 0, over negative 4 minus 0, I get 6 over negative 4. I don't care where you put the negative sign. I always like to put it in the numerator. And you get negative 3 over 2. You can put it out front too if you want. Notice, they are not opposite reciprocals. So this answer is neither. Let's turn around and see what happens when we do letter B. Let's start with the slope of E to F. Notice E is at 3, 6. F is at 6, negative 1. So to find the slope, I'll pick one of my y coordinates. I'll call that my second one. So I'll say 6 minus a negative 1 all over 3 minus 6. 6 minus a negative 1 is 7. 3 minus 6 is negative 3. So I know my slope is negative 7 over 3. And once again, it kind of looks like it might be perpendicular. So I'm going to turn around. I'm going to find the slope of D to G. If you think ahead, what does the slope have to be? Well, it'll have to be 3/7, won't it? So then I'm going to look at my coordinates of D, which is at negative 2, negative 1, and G, which is at 12 and 5. So I'm going to say 5 minus a negative 1 over 12 minus a negative 2. Five plus 1 is 6. 12 plus 2 is 14. I divide by 2. I get 3/7. Notice they are opposite reciprocals. So on this one, we know EF is perpendicular to DG. It won't select for me. There we go. And we'll do the next page in the next video.